Normally the quadratic equations start with x square, and then we have x term, and then the constant equal to 0. That is like this. But this equation, it looks like quadratic, but if we convert this using some coded substitution, so this will exactly look like this. So let's see how to do and how to use coded information in this quadratic equation so that it can look like this, and then we'll solve it to find the value of x. So for that, look at this term, which is x square, and let this term x square is equal to y, and plug in this in the equation. As we can write this x power 4 like this, x square power x square. So just plug in here the value. So this x square will become y, and this square, it will become y square, and this x square is y minus 72 equal to 0. Now this is the standard quadratic equation which we normally use to solve the equation. Now using any method, we will find the values of y. Therefore the solution is y is equal to minus 9 and y is equal to plus 8. These are the values of y which we have obtained from this equation. But our actual equation, it is in x, and we supposed y x square. Now what we'll do, we will use x square in place of y. So the x square will be minus 9 and x square will be 8 here. As a square number cannot be negative, so this is invalid solution. Now from this x, let us take square root on both sides, 8, and we will use plus minus sign here. Square with cancel square root. So the solution, final solution of this is x is equal to minus square root 8 and plus square root of 8. These are the solution of this quadratic equation. And this is another example here. So if we write like this, this look as if it is a quadratic. Now concentrate over here and on this term, and suppose let it 1 over x square is equal to y. So this equation will become 3 plus 2y is equal to y square. Now it looks standard quadratic equation. Converting into a standard quadratic equation, we get this equation, and now using any method to find the value of y, we will get y minus 1 or 3. And these are the solution of this equation from this equation, but our actual equation is this one, in which we have used x. Here y was 1 over x square. So we will substitute here 1 over x square is equal to minus 1. By cross multiply, x square will be minus 1. And as we know that the square cannot be negative, so this is invalid. And what about here? This side, use this again. 1 over x square is equal to 3, and x square is equal to 1 over 3, taking the square root on both sides. when we take square root, it is plus minus, so cancel. So x is plus minus square root of 1 over 3. And these are the solution of this equation. X 1 over under root 3 and or minus 1 over under root 3.